Welcome back. In our last explainer, we really dug into the mind of the consumer. Today we're going to flip the script and look at things from the other side of the market, from the producer's point of view. We're going to explore how a firm makes its decisions all the way from the production line to the final costs.
Okay, let's just jump right in. At its very core, a firm's job is pretty simple. It takes inputs, we're talking labor, machines, raw materials, and it transforms them into outputs, the goods and services we all use. This slide shows you exactly that. It's that magical process of turning a bunch of stuff into something valuable.
So, to really get our heads around this whole thing, we're going to follow the journey of a single firm. And this firm, like pretty much any firm out there, has one main goal, one North Star, to maximize its profit. That single motive is what drives every single decision it's going to make.
You could say that every firm has its own secret recipe. In economics, we call this recipe the production function. Now, don't let the name fool you. It's basically a technical relationship that tells you the absolute maximum output you can squeeze out of a given set of inputs. It's all about being as efficient as possible.
So the most crucial point here is that output, which we just call Q for short, is totally dependent on the inputs you use. Now, just to keep things simple, like you see on the slide, we're only going to focus on two inputs, factor 1 and factor 2. You can think of these as the classic duo, labor and capital.
All right, now here's where it gets really interesting. A producer has to make decisions across two totally different time frames. And in economics, we're not talking about days or weeks. It's all about how much flexibility the firm has to change things up. Let's see what that really means.
And that brings us to this big idea, the short run versus the long run. So in the short run, at least one of your inputs is stuck. It's fixed. Think about a factory building or some massive piece of machinery. You just can't change that overnight. But in the long run, well, enough time has gone by that you have the freedom to change everything, even build a whole new factory if you want to.
So let's zoom in on the short run first. This is where the firm is kind of stuck working with its fixed inputs. If it wants to produce more, really its only choice is to change the things it can change, the variable inputs, like hiring more people.
Let's just say for a minute that capital is our fixed input, and we're only adding more labor. Now look closely at this table. When we add the first few workers, each new person adds a ton to our total production. Just look at that marginal product, or MP column. See that? It jumps from 10 to 14 and then all the way up to 16. But watch what happens after that third worker. Things start getting crowded. You've got more people trying to use the same machines, and you start seeing diminishing returns. The MP drops to 10, then 6, then all the way down to 1. That right there is the law of variable proportions in a nutshell.
Now what's really cool is when you see these numbers on a graph. Notice the total product curve? It has this very distinct inverted S shape. It shoots up fast, and then it starts to flatten out. And right below it, you've got the average and marginal product curves, forming these classic inverted U shapes. This picture is the textbook illustration of the law of diminishing marginal product in action. It's one of the most fundamental laws in all of production theory.
And this slide, well, it just brilliantly lays out the mathematical dance between marginal and average product. Think of it like your grades. As long as your score on the next test, your marginal grade, is higher than your overall average, it's going to pull that average up. You can see the AP curve rising when MP is above it. But the second your test score dips below your average, it starts to drag the whole thing down. Seriously, understanding this relationship is absolutely crucial, especially for competitive exams like the UPSC.
Okay, let's shift gears and jump into the long run, the world where everything is variable. In this world, a producer starts thinking about scale. The big question becomes, if I double all of my inputs, my factory, my workers, everything, will my output also double? Or will it maybe more than double, or less?
That question is answered by this very important concept called returns to scale. It's all about measuring how output responds when a firm decides to scale up and increase all of its inputs at the same time by the same percentage. And believe me, this isn't just theory. This is a massive deal for long-run business strategy. It affects everything from how a company grows to the entire structure of an industry.
So there are basically three ways this can play out. At first, a small firm might get way more efficient as it grows. That's increasing returns to scale. Then it might hit a sweet spot with constant returns. But if a company gets too big, too bloated, it can become a nightmare to manage, leading to decreasing returns to scale. This actually helps explain why some industries, like software, have a few giant players, while others, like local restaurants, can have tons of small, successful businesses.
Of course, none of this production happens for free.
Every firm has to pay for its inputs, and that's what we call the cost of production. To figure out its profit, all the firm has to do is take its total revenue and subtract all these costs. Simple as that.
In the short run, the total cost is broken into two parts. First, you've got your total fixed costs, or TFC. These don't change no matter how much you produce. Think of the monthly rent for your factory. Then you have your total variable costs, or TVC, which definitely do change with output, like the cost of raw materials or paying your workers' wages.
When you put this on a graph, it's pretty clear. The total fixed cost is just a flat, horizontal line because, well, it's constant. The total variable cost and the total cost curves, on the other hand, both slope upwards. Makes sense, right? The more you produce, the higher your variable costs. And notice how the total cost curve doesn't start at zero. It starts up at the level of the TFC, because even if you produce nothing, you still got to pay the rent.
All right, now for what I think is the most important graph, per unit costs. The real hero of this entire story is the short-run marginal cost curve, the SMC. Its behavior is what dictates the shape of all the other average curves. You'll notice they're all U-shaped, which is a perfect mirror image of the production curves we looked at earlier. Costs go down at first because production is efficient, and then they start to rise because of those diminishing returns. It's all connected.
So if you remember just one rule from all of this, make it this one. This is the golden link between production and cost. As long as the cost of making one more unit is below the average, it pulls the average down. The very moment that marginal cost rises above the average, it starts yanking the average up. That's why the marginal cost curve will always, always, always intersect the average cost curves at their absolute lowest point.
And that's it. That's the story of a firm, from its production recipe all the way to its cost structure. We've hit the big ideas of the short run and the long run. Now, it's your turn. Let's see what you've learned.
First question for you. Why is that short-run average cost curve, the SAC, almost always U-shaped? And what big economic law that we just talked about is it reflecting? Give it some thought.
Okay, second question, the law of diminishing marginal returns and decreasing returns to scale. They sound kind of similar, I know. But what is the fundamental difference between them? I'll give you a hint. Think about the time horizon, and think about how many inputs are changing.
And for our final question, a little bit of a brain teaser. If the marginal product is falling, does that automatically mean that the average product has to be falling too? Explain why or why not. Go ahead and drop your answers in the comments below. We'll see you in the next explainer.